Hi, so we're going to talk about graphs of inverse functions. Inverse functions are functions that undo each other, and you'll be able to see that when we start looking at these graphs. So the first graph is going to be of y equals x cubed, and the second one is going to be of the cube root of x. All right, there we go. And you can see that they're the same shape. The cube root graph has just kind of been swirled around somehow. We're going to talk about what that means exactly in just a minute. You need to draw them both on the same set of axes now so you can see them together. First, there's a point. So what happens with inverse functions is every point on one of them is flipped on the other one. So the x becomes the y and the y becomes the x. So that's true of the whole domain and range as well. The domain becomes the range and the range becomes the domain of the inverse function. So whenever you know a point on one graph, if you just swap the x and y, you know a point on the other graph. This is what the two of them look like on the same graph. And I'm drawing a dashed line here of y equals x. And the inverse functions are always kind of reflected across y equals x. Why? Because y becomes x and x becomes y. So that's the reason that y equals x is the reflection. And this time I'm just drawing some random function. I had no idea what the equation is. I just drew a curve. And because I know the inverse function is reflected across y equals x, I can draw the inverse function to match it. So that's the inverse function. It's got to be because it's got to reflect across y equals x. So hopefully this gives you some understanding of what's going on with the graph. And again, any point, so I'm labeling AB could be any point on one graph is going to be flipped on the other graph. Just think, swap the x and y, and you're done.